Hello and a warm welcome and greetings from Berlin to today's webinar as part of the Tudio Academy series. And the topic today is simply better models and MXAM in action. And first, before we get right into the topic, some organizational info is that when you have questions during the webinar, you can use the WebEx Q&A for this to pose your questions, and we will take some time to answer these at the end of the webinar. And if you would like to rewatch the webinar, or you may know someone who can be interested in it, this is no problem. So this session is recorded and it will be uploaded at the video section on our MES website. And the same goes for the slides. So the slides you will receive afterwards the webinar via email. Then let's get right in. So my name is Kai Teschner. I'm a product application engineer for the MES Model Examiner at Model Engineering Solutions. And we at Model Engineering Solutions strive for a world of safe technology in mobility. And for that reason, we offer tools and expertise that ensure the quality and safety of embedded software. And in particular, this consists of three focus topics, the MES portfolio. So first of all, the simply better models, where we focus on static model testing with the MES Model Examiner and MES Model and Refactor. So this is the point, or the bubble here we want to dive in further in this webinar. Then we have a second focal point is the Tudio Academy, which starts as a knowledge hub to present webinars like this, trainings, and as well as e-learning and other types of information. So the third focal point is quality and control, where it is separated into two things. So one is the focus on the quality of software development projects with the MES Quality Commander. So another tool, and the other aspect is that this also includes project to implement model-based development or the development of safety relevant software in MBD processes and consulting. And over the more than 15 years, we also gained a wide range of customers, which you can see here. So I said that we focusing on the simply better model part and on the tool parts here. And our tool portfolio is primarily located when viewed from the development cycle view on the left side of the V model. So a range of tools we offer there to ensure the quality of the software design. First, you see here the MES Model Examiner, which is an automated guideline checker. So as I think most of you will know here, to check guidelines, verify architecture, properties, correct unit design, and the implementation of your model. We as well offer MES Model and Refactor as a toolbox for Simulink to design to enhance modeling and refactoring, addressing repetitive activities, as well as good layout in your models. And the third tool already mentioned in the focal point of software and quality is for quality control and monitoring, the MES Quality Commander, which oversees the activities throughout the whole development lifecycle of your software. But since this is now the webinar on MXAM in action, so we will see or we will get to see MXAM a little bit more, respectively, really focusing on the Simply Better model part. So this webinar consists, or you can split it up into 4 different parts, where I would like to maybe take a step back again, motivate the static testing. Then we will see how MXAM is really the guide to better modeling. And then we will see what to do, how to achieve simply better models. And this is concluded with a live demo. So, but let's take the aforementioned step back and see static testing and the MES Model Examiner, which that we come back to the V model. So where we have the different sides of the V model, and we already saw that the MES tools are focusing on the left-hand side of the V model, consisting of the design phases, and we see on the right-hand side there we have the test phases. And the test phases, they care about the functional quality of the software. So more or less to say the fitness of the functionality. And this tackles the question, okay, have I done the right thing, or have I done the right thing developed? As for the other hand, it goes for the design phases, which non-surprising, focusing on the design quality and the suitability of the design. So tackling the question, so have I done it the right way? And one thing which is as well good in model-based developing, since we developed the model from the right start here, is that also the design quality is as vital as the functional quality. So because the suitability of the design really facilitates the fitness of the functionality. And in order to ensure the quality of the design, we can front load the quality assurance here with the static testing of models. And with that, we can improve the quality of the model and the developed software even before code is generated, so that we can really start with the quality assurance at first stages at the development. And so therefore the MES Model Examiner, or short MXAM, does the static testing highly automatically. So in order to increase the readability, the robustness, and in order to avoid errors. So because it can cost you much when you really detect errors late in the development process. And as well, as I mentioned, we can assure the design quality even before we generate code. So this meaning, with a good design quality of a model, you as well improve the generated code. So let's see how this is done in detail, and with a small picture example. So this is a very small subsystem here, but when we now assign to review it, so we may stumble upon different things that are not a good design quality. So for instance, when we see or tackle the question, okay, so how is the interface? So we have a look at this. So we see at first regarding the readability that maybe the signal flow is not that good. We see we have these are not aligned. So you see here's a hidden in port, which is not directly visible. This as well goes for this block here, which is not visible. So already, yeah, two things that are not part of a good design quality. So we as well see here some magic numbers, which will as well then transferred into the generated code, where we as well want to avoid magic numbers. And then we as well, so this maybe not, or one thing we really not see at the first glance. So, but we see that we have a product block here consisting of 3 inputs. And yeah, when regards to come to floating point numbers, so this is not a good way to go because of the floating point numbers and the different scaling. So it is really safer in order to avoid unexpected behavior to split these calculations into 2 blocks here. But this only in this small example already some parts in regards of the design quality, and therefore we can statically test this model and in order to improve this from the results. There we see that we have replaced the magic numbers. We see a direct signal flow here. We now see what this block is about and has as well, in order to avoid these unexpected behavior, rearranged these product blocks here. And how does the MES Model Examiner does this content-wise? So, so the users of MXAM know this. So, in order to evaluate the design qualities in the last decades, it was established that we have modeling guidelines coming from different standards, like from MISRA and as well the MathWorks Advisory Board. And we also at MES, as experts in functional safety, have published our own modeling guidelines document, which tackles several topics, like we saw the model layout, a data and control flow, data typing, which is influencing the generated code, and also configurations in and around the model, and as well configurations for the automatic code generation. So on the other hand, we have as well the MXAM as well assesses the application of design principles via different model metrics, and these are derived from standards. So for example, the functional safety standard ISO 26262 has several design principles for software architectural design recommendations, and in order to assess if we follow these recommended design principles, we can use metrics, which mapping certain numbers to specific model parts in order to see how good we executed these design principles. And these metrics come in different forms, so like a complexity metric, so different sizes, as well as the size of the interface or the subsystem in general, and as well when it comes to the coherence, loose coupling between software components, there's one metric as well to assess these principles. So now, as we now know what is analyzed, so when we can have a look at a typical agile working day when developing the model, and we want to ensure the suitability of the design quality, so that we really would like to analyze our model in respect of the design quality, and want to have a report in a certain way that we can really see what is the quality, and we would also wish for that we have several guidance and hints. Okay, so what to do now in order to improve our model and improve the design quality of the model in the end, in order to achieve these simply better models. So there, one would now see, when we have such a report, when we now know what is really analyzed automatically. So question now would be, okay, so where to take action now? And this is now the point where we come to see where MXAM is now really your guide to better modeling. And therefore we want to have a look at the different sections of an analysis report of MXAM. So at first we have, and we will later see this again in the live demo, we have the document navigation, where we can start from the point of view of the guideline document to see our design quality there and where we want to improve. But you can as well take this from the, we call it artifact navigation, so really from the point of view of the model hierarchy, where we have as well here in this picture enabled the number of findings, so that we can directly into a certain subsystem that may need the most attention. So for instance, we see here the subsystem airflow calculation at the first glance seems to have the most findings. So here in the document navigation, we have the document and can see, can tackle the different findings per guideline and guideline chapter. And on the other hand, when we want to tackle it from the point of view of the model hierarchy, we can use the artifact navigation. And then we can have, per this navigation, listed all the findings. So for instance, when we now want to see which findings are in the airflow calculation, we get this in such a table list. And from the table list, we can drill down further really to the details of these findings, where it is explicitly said what is the guideline violation, and there are as well direct links into the model. So with the with MXAM, you have always the direct connection to MATLAB Simulink, and from there on you can really directly have a look at the affected part in the model. And as this is not only the guide where to take action, so also a thing or a good guidance is to what to do now. And therefore you can as well directly from the report have a look at the documentation of the guideline and the check, and see that there is for each check a proposed solution and as well a repair action which can be carried out. So this leads us to now then, after we have answered the question, so now where to take action in order to increase the design quality of my model is now how to take the action in order to achieve these simply better models. So in there, we again get back to these examples. So we have now here two solutions which are pretty straightforward. So in regards that we have a consistent signal naming throughout the model to increase the readability and as well to have a good mapping from model to generated code. It is clear that we want to have a consistent naming, and therefore one thing that supports this is to set the property, the Simulink property show propagated signals to on. And as well, also when it comes to switch blocks or other blocks, so there's as well an option to require all inputs to have the same data type. Again, in order to avoid unexpected behavior, for instance. And when we now look at this proposed solution, so we can see that these tasks to improve this model and resolve the guideline violation, we see that this is a unique solution. Pretty straightforward and easy to just select an option or switch something to on. And in order we have this in several parts of the model, so it is as well a repetitive task and may deflect from our really functional modeling activities. So one thing is that we can wish for is to automate and assist this solution, and therefore we can use the MES Model Examiner to directly repair the finding from the report. And this is one thing we will as well later see in the live demo. So here, for instance, you see that there are empty signal lines. So this example of the signal propagation is not switched on. And in order to support the modeler here, that he or she does not have to go on each signal line and switch it on, you can just do the repair action, and we see signal name is now propagated, and this repair action then can also be done for the whole model, so that the whole model then afterwards follows this guideline. So now it also may happen that there is a guideline violation that maybe has not that easy solution or unique solution. And we also talked about these model metrics. So in regards of when we want to achieve a strong coherence between components or to lower the complexity. So these are more complex tasks. So I have two examples here. So one is when it comes to layouting guidelines as well, when it's just change the layout of your model in order to achieve a signal flow from left to right, for instance. And as well when it comes to the complexity, it says, so if it is too high, so try simplify it using different blocks, subdividing subsystem into smaller subsystems. So things or solutions that require more complex tasks consisting of combined modeling actions. And these may again also be multiple and repetitive modeling actions, and may as well, when it comes to this layout, that you have really hard to tackle fiddly layout options. And therefore, for this kind of solution, it would be great to facilitate and automate those actions for layout, especially, and as well for refactoring and partitioning of models. And therefore, when you recall, the beginning was the tool MES Model and Refactor, developed in order to support the modeler with these problems. And as you see in this small video, where a subsystem is taken and carried or decomposed into several parts, layout is changed. So this is one task you can tackle with more. And now the good news is I can present you in this webinar is that, like we had seen in the slides now, that the MES Model Examiner now integrates MES Model and Refactor, so that more is now installed together with the latest released MXAM 10. The more actions and the tool itself can be directly used with the same license. And as we can conclude already from these slides, so that the more actions, or that there's a synergy between the analysis capabilities, reporting and repair capabilities of MXAM, and the more modeling actions, so that the integration of more into MXAM is the best addition on the way to better models. And there I think we now come to the question, how does this now look into practice? And then we would see to have the live demo here. So now this is now the MXAM 10. I have already run an analysis here on a model which I opened, and we get the report here, where we have on the tabs the document navigation, and as well as I said, the artifact navigation, where they show a number of findings that is also already enabled, so that you can really, like shown on the slide, really see, is there a subsystem that has the most findings or needs the most attention. And this can also be done for the document navigation, that you can see, is there maybe a guideline which has one of the most violations. And when we have a look here, so we see here the aforementioned example, the propagation of signal names. We have 52 findings here. When you then go on from this document perspective, we see here for this guideline, then like we saw, we have listed all the findings here in a little bit more detailed. And then we can use this table in order to click through the findings and see really or drill down to the details here, where you have as well the direct link into the model. So when we just see the link here, so we see there's no signal name. So it seems, or it is clear that the propagation is not enabled there. And then we have as well other failed findings. So like I said, we want to ensure a consistent naming throughout the model, which also includes that the model should be named at the source signal. So for instance, here we have a signal line named, we see here, but it is not not the source signal, and we can also directly see. So this is the source signal where the bus is created. So it is not named there, but in between. And this, these links really help you to understand the guideline violations more here with the link onto the signal line, and as well guides you to the source signal. So now we saw this in the slides that this is one guideline violation that can be automatically repaired. This you can as well see on this icon here, this little cross with the wrench. You can as well see it here on the repair update, that the repair option here is set to yes. But the best way to do, where you can also set the number of findings, is to show the repairable checks only. And then, you have only you can view only these checks that are repairable. And now how to do this. So I would like to make this a little bit with a split screen. So because when we want to repair it now, so you can right click here on the finding, but as well can do a multi-selection, for instance, or directly in this list here, click on repair findings to see all 52 findings. And there now you get this dialog, which is which shows you a transparent way. Again, what is the guideline violation? So we had here this is named but not the source signal, and what now the repair action is doing. So for instance, to get out of this violation, this is clear since we want to name it on the source, not allowed to rename it, that the name is set to, that this is set to empty. So, but I wanted to start with the signal propagation. So again, we saw this already, and there, this was the unique clear solution to set it to on. And now you have the full controllability here. See, this is set to on. Apply it all, see that this is on, and again, get step by step through these repair actions with the highlight into the model. And then you can as well, when you say, I really, I have my trust into the repair action here, that you can say, okay, apply all, so that then now it goes through all the findings and applies it. And this can as well be done for the other findings we have, so where we set the name to empty. So we see that this was named empty, and then we can just say, okay, apply all when we really see that this is doing right, and we see that we have repaired the findings here and repaired it here as well. And then you can really, by proving it, to rerun the checks here, or rerun all checks for the guideline, in order to see that we have now a passed guideline, so that we have now improved our model in regards of the signal naming consistency. So this is the one thing we had in the slides to tackle guideline violations with unique solutions, so that the MES Model Examiner helps you with the automatic repair action, in kind of a transparent way, with the links into the model, with a good controllability, in order that you can really choose how many findings I want to repair, and as well want to apply them step by step or want to apply them all, and as well to really see in the model what is it doing in a really reliable way. But let's go over or move over to the model metrics we talked as well in the slide. So let's get back to all the findings. So we see at the chapter at model architecture, there's one fail finding which is talking about the local complexity, which is higher than a configured boundary. So because it always in this model metrics, it always depends on your experience how to handle these number, and as well how big your models are in your organization. So for this example, we have made this as the boundary for a local complexity of subsystems. These metrics can also be seen here in this table, where again you see per each subsystem the metrics. So we see here the complexity. There are some easy metrics like number of outputs and imports, unused inputs. So the effectiveness of interfaces, really important for testability, for instance. Also the incoherence I talked about. So really different metrics. So as well, the mixture of functional blocks and structural blocks here. So there are several metrics available in the static testing that assess the application of these design principles from the ISO 26262. But let's now tackle the with the high complexity, and there again we can see the solution here. We had this already as an example. It was they try to simplify by using different blocks as one proposal, or subdividing the content into smaller subsystems. So let's first of all go into the subsystem itself. So, and we may see at the first glance so that there is a mixture of functional blocks, but also structural blocks with the subsystems here. We see that there are several go-to-from blocks, and it seems, so when we see like this, that there are as well different calculations that may or that can be separated. And now in order to divide this or refactor this, so we can now the MES model and refactor, which I said is a toolbox for Simulink. This can be accessed here in the tool strip, and as well by right-clicking into the model. And again, so what was the news at the end of the slide, so that this is now integrated into MXAM 10. So when you're choosing to work with MXAM 10 or upgrading to MXAM 10, so you have this already or you get this as a package here. So, and you see here these different actions. So we have several layout actions, things for interface, signal routing, and two of the, I would say big actions are auto and refine layout. And maybe in order to get a good overview here, let's start with an auto layout here. Okay, so a little bit arranged better, where we can maybe see better that there are several calculations that may be separated or candidates to put these into smaller subsystems. One advice was also to use different blocks. And I think in order to increase the readability and maintainability, we can get rid of these go to from blocks. And therefore we have the actions for signal rounding to convert these to signal lines. So now we reduced as well the number of blocks in general. And I think then we can maybe also already see that maybe these different lookup tables to calculate these different signals we can put in a subsystem where we have as well an action from MES more. And maybe do another auto layout. So I think then we can put this into a subsystem. And as well this above here. So the create subsystem action from more is a little bit more sophisticated. So the Simulink actions really put or really is creating very small subsystems. So as you see, it tries to retain the size of the blocks before, and there's also the benefit that the ports are automatically named by the signals that are here, and as well, more is as well really looking back the signal chains to name them. So this also in regards of signal consistency here. And now let's see, maybe we want to have this bus selector out of here and maybe take care of the feedback loop, which is a guideline to really have this outside. So let's put the last subsystem here and do as a last polish a auto layout so that we can now, or that we have now decomposed or put this complex subsystem into smaller subsystems, which then when we just look in it are less complex, so that we have really a low complexity per subsystem here. And as well maybe especially for this case, not again a mixture of structural blocks and functional blocks. So, and afterwards, when we tackle these, to load this complexity with these refactoring options, we can as well now go back and do a reanalysis of the model. In order to see if we decreased the complexity there. Yeah, this looks good. We, maybe we forgot to name the new subsystems properly. So we have now, decreased it as well as under the boundary of 100. So, but we are, down or under the boundary of 300, where we decided on that these are too complex. So really, in order to increase the maintainability as well as the modularity and the readability of these subsystems. And this is one. So the practical part how to gain simply better models, which are shown in the slide, so that we have the analysis of guidelines and calculating of model metrics from the static testing, and from there on we can resolve these problems and improve the model quality with the help of the automatic repair function and the modeling actions. And therefore I would like to summarize it again in these agile circle. So we talked about the motivation for static testing, and showed that the MES Model Examiner highly automatically does this analysis of the modeling guidelines coming from different standards and calculating the model metrics. We had a look at the reports in order to see how good is our design quality of the model, and as well as our guide to better modeling saw how we have hints where to take action, and then the hints what to take action in order to fix things, resolve guideline violations, and improve the model in general. And this we have done with the help of both of the tools from our focal point Simply Better Models here at MES, so that we have the analysis, the report, and as well the automatic repair function as part of the MES Model Examiner. We saw that we, with the one example, to lower the complexity of subsystems in order to improve them in regards of maintainability, modularity, readability, that we can use the layout and modeling actions from MES Model and Refactor. But there are as well some guideline violations that can be tackled with the more actions. And then some of the more actions are really also suitable for the modeling in general when it really comes to the functional modeling. And then in the end, in order to get to these simply better models. We have. I'm back with some questions you ask. So there's one question about M code. So there's the question: is M code in the model analyzed both in charts and in MATLAB function blocks? Very good question. So first of all, we're focusing on analyzing the model. So the code in MATLAB function block is not analyzed. So, but when it comes to Stateflow, there is the code of state actions and transitions and so on. So this is analyzed as well, but not really the M code of MATLAB function blocks. So this is split up. So your question, so in charts, the code is analyzed as well, and in MATLAB function block not. Then there's also a question about the automatic repair function when using or when analyzing the model in batch. Very interesting question. So in order to not only automate the analysis, but as well the repair function. So what I can say, so there is a call to repair all repairable guideline violations from the last report. So this, I think, maybe will be developed further in the future. So this would really be the big solution to really say, okay, I make the analysis and repair all guideline violations as well in a batch one, and then I take care about the more complex solution. So this is a really good question. So, but and there's also a solution, but only not very configurable yet. Just to say, I make an analysis, I have a report, and please repair all repairable violations from this report. Then there is the last question: why sometimes in MEXAM 7.0 abort some check, and what is the best way to make it run again? There, I have to say, so that when the check aborts, so this really is not good. So then there's really a technical problem. So I would say that you can contact us via support@model-engineers.com. So we really have a strong support so that we can really have a look at these technical problem in detail. So because when a check aborts, so this is really a technical problem with the tool or MATLAB, but really not with the model. So there I would propose to send us an email into our support. Okay, great. Then, yeah, thanks for the questions. Then I would, like to conclude this webinar with the announcement for our next webinar, which is about the, so to say, new functional safety standard beyond functional safety, the standard of the intended functionality, so called SOTIF, which is done on Friday, the 1st of March. And there's also new, I think, first release some days ago, our new newsletter on LinkedIn to get the latest updates on MXAM when there's a new release, and as well some things beyond that. And as well, so like I said, this webinar is recorded, so you can as well have a look at our videos on the MES website, where we as well have several videos for the MES Model Examiner and as well for actions from MES Model and Refactor. And you can as well see the recordings of the webinars there. And would like to, and always happy to connect with you. So via several of these channels, and this would let me only to say that as announced on 3 p.m. In my time zone here, the end. And thank you really for listening, and thank you for asking questions. And I would wish you a nice rest of the day and a nice weekend. Goodbye.